Dalton's laws, slide 1. The ancient Greeks were the first people known to have an atomic view of nature. They believed that all matter was composed of just four elements: earth, fire, wind, and water. Furthermore, they thought each of those elements was composed of the smallest possible piece, or atom. The idea, though incorrect, had the essential pieces of modern atomic theory, and in the 19th century, John Dalton used this idea to create the first modern atomic theory. Slide 2. Let's assume we have a town with a population of 1,000 people. If half of those people went and formed another town, would each town still consist of a population of people? The answer is obvious. Yes, each town would have 500 people in it. Now imagine each town divided again. Would each town still consist of a population of people? Again, the answer is yes. But is there a point at which we could no longer divide the towns and still have a population? I'm certain you would say yes. After all, if the population of the town consists of only one person, it cannot be divided. It turns out matter behaves in a similar way. All normal matter is made of elements, which are composed of individual atoms. The atom is the smallest possible piece of an element, and it cannot be further decomposed by normal chemical means. The ancient Greeks were the first to recognize that matter had to be made of smallest possible pieces. They called these pieces atomos, and in their honor, we now call them atoms. However, it took nearly 2.5 millennia to reach a modern atomic theory. For the first real atomic theory was created by John Dalton more than 2 centuries ago. He knew that matter was composed of elements, which could not be further decomposed by chemical means. Furthermore, he knew the Greek concept of the atom, and he merged it with his understanding of elements into a new atomic theory that had 5 laws. Now we will present them with some modern interpretation, but he got them essentially correct. First, all elements are made of atoms. Second, all atoms of a given element are identical. Third, all atoms of different elements are different. Fourth, atoms can combine in simple whole number ratios to form molecules. Fifth, atoms are immutable, that is, they cannot be decomposed. Slide 3. Atoms are immutable in normal chemical reactions, but they are made of smaller particles. There are 3, and the first is the proton. It has a mass of 1 AMU, or atomic mass unit, which is equal to 1.675 times 10 to the negative 27th kilograms. We use the atomic mass unit for protons because it is more convenient given the small size of the atom. The proton is positively charged, and we say it is plus 1 in atomic units, which is equal to 1.602 times 10 to the negative 19th coulombs. Second is the electron, and it has a mass of 0.00055 AMU, or 9.109 times 10 to the negative 31st kilograms. Like the proton, it has a charge, only it is negative, and its value is negative 1, or 1.602 times 10 to the negative 19th coulombs. Third is the neutron, and it has a mass of 1 AMU, or 1.675 times 10 to the negative 27th kilograms, and no charge.